A quadratic function is any function that can be written in this form. F of x is equal to ax squared plus bx plus c. And what's important to note about these functions, it's different from the linear functions we've worked with before, is that there is a squared term, and that's the highest degree term. The graph of a quadratic function is a shape called a parabola, and it may open upward or it may open downward. And you can look at the equation and know right away which type of parabola you're going to have. If the value of a, the lead coefficient in the function, is a positive number, your graph opens up. If the lead coefficient is a negative number, the graph's going to open downward. Every parabola has a vertex. And on a parabola that opens upward, the vertex is the lowest point or the minimum point. On a parabola that opens downward, the vertex is the highest point or the maximum point. So the vertex, if we're going to kind of define this, come back. The vertex is the maximum point or minimum point. Every parabola also has what's referred to as an axis of symmetry. It's going to be a line of symmetry. In these cases, a vertical line that kind of splits the parabola in half. You'll sometimes hear that referred to as the axis of the parabola or axis of symmetry. So it divides the parabola in half. And it's also worth noting that that line always intersects the vertex. So the line is where, it's going to go through the vertex. Now, the most simple quadratic function is f of x equals x squared. Okay, that of course could be written as in equation form as y equals x squared. And we start with that one because we already know what it looks like. We know what the graph of y equals x squared looks like, and it's this curve right here. You'll notice that since the coefficient a is greater than 0, this parabola opens upward. The vertex is the origin, and the axis is the vertical line. So when you're giving the equation, when you're giving me the axis, give me an equation, x equals, and it's always the x coordinate of your vertex. So in this case, it's x equals 0. Now, every other parabola, every other quadratic function is a transformation of this very basic y equals x squared function. And the standard form for a parabola, for the equation of a parabola, is a times the quantity x minus h squared plus k. And if you kind of think about comparing that to f of x equals x squared, the coefficient a here determines what type of vertical stretching and shrinking there's been. And if a is negative, there's also been reflection over the x-axis. Whatever number is taken away from x represents horizontal shift, so shift left and right, and whatever number is added to the entire thing represents vertical shift, so shift up and down. The vertex, sometimes this standard form is called vertex form because you can look at the equation and these values, h and k, are the coordinates of the vertex. You can just pull the vertex out of the equation. And if you know the vertex, then you know the axis is x equals that x coordinate. Now, when you sketch a parabola, I'm going to ask you to do a little better job than Professor Ward does on the video you're going to watch in just a minute. When you sketch, I'd like you to give me as accurate a graph as you can, which means I need you to find the vertex, I need you to find the axis, okay, and when I say find them, figure out what they are and sketch them on your graph. It actually helps you draw the picture correctly. Plot the point for the vertex, draw the line for the axis. I also want x-intercepts and y-intercept. And if you have to plot another point or two to get a good accurate curve, then do that. Pick out some values for x, plug them in, figure out what the y value is.